Hello everyone, welcome to another video lecture of Mathematics Solution channel. In this video lecture, we are going to discuss about indeterminate forms. What is mean by indeterminate forms, right? What is mean by indeterminate form? Suppose I have the function f of x. If let us take some function, I have that is f of x is any function at the point x is equal to a, right? If I substitute or if I apply that such a limit x tends to a, okay, assumes that you are getting some different values, okay, or different expression. That expression is maybe you will get like infinity by infinity, 0 by 0, or infinity by 0, or 0 by infinity, or not only this thing, okay, we have so many things. Maybe infinity into infinity, 0 into 0, 0 into infinity, infinity into 0, or infinity minus infinity. Whether up to that? No, we have many more things, okay. One, it is 0 power 0, okay, infinity power 0, 0 power infinity, or infinity power infinity, and one special case. So we are not supposed to say this is special case, but we people are thinking that 1 power infinity, how can you say that it is indeterminate forms? That means what? It should not give any finite value. So that is called the indeterminate form. So what it will give exactly? So we cannot say that this is the value for that such function. Suppose I have the function form like some 2 by 3 or 4 by 2. I can say that it is 2. Correct? If it is 2 by 6, we can write 1 by 3. Okay, so we can say that these such values are having a finite value. But if you go here, okay, we cannot say these values are having such a value like finite value. We cannot express it in the finite value. Such expressions are called, or such forms are called indeterminate forms. Okay, then how to find or how to simplify such values? Okay, here I have some expression. Let us take some type 1, type 2, type 3. Okay, later I will explain why 1 power infinity is indeterminate form. Okay, and before that, how to solve such kind of problems? So that is called, that rule is called LHospital rule. What it says LHospital rule? If I applied, what you will get? Suppose I have the form like this, 0 by 0 or infinity by infinity for such a function, okay, and if I applied LHospital rule, then what will happen, or how to apply that? Anyhow, you will get a by b form. Let us take some a by b form where a and b are 0 or infinity, okay, so that will cover entire things, okay. If you have that, then definitely you will get a fraction a by b, that is numerator and a denominator. So what it says, no need to apply UV rule, directly differentiate independently the numerator and the denominator. Is it clear? Directly differentiate the numerator and the denominator independently or separately. Then again apply the limit. Again, if you get the same indeterminate form, then again apply the LHospital rule until you will get the finite value. You need to apply continuously to the LHospital rule. Okay, so that's the first thing. Second thing, suppose instead of getting a by b, if I get 0 into 0 or a by b form, then how can I bring into that a by b form? Suppose I have the function here x into some e power x, right? If you apply just a minute, I will take another problem, x into log x. If you apply 0, limit x tends to 0, what will happen? This will become 0 into log 0 is minus infinity, correct? 0 into minus infinity. But when I can apply the LHospital rule, once if you bring the form as a by b, that means what? 1 among these 4, right? So then only it is possible to apply the LHospital rule. How can I bring? I know how can write this LS, that is log x divided by again 1 over x. Yes, obviously we can write it, correct? Then if you simplify, again you will get the original form. Then you can apply the limit. What will happen? This will become minus infinity 1 by 0, that will be that will become infinity. Now I got like a infinity by infinity form. Now we can differentiate the numerator and the denominator separately, okay, and apply the limit. Maybe you will get the finite value. So if not, again apply limit. I mean, what is that? LHospital rule, until you get the finite value. So this is the second one. The third one, what is the third one? We have some, I have given some expression, 0 power 0, infinity power infinity, infinity power 0, like that. In any problem, if I get this kind of form, what I want to do, let us take x power sine x power limit x tends to 0, right? In limit x tends to 0, if you substitute that, what you will get? 0 power 0. Yes, I got it 0 power 0, but to finding the finite value, I want to bring the term as a by b, then only is possible to apply the LHospital rule. For that, what I will do now, I will consider as a k. Now I will take log on both sides. So log k is equal to what happen? So limit x tends to 0 log of x power sine x. Okay, now this will become a log a power m form. So you can write simply limit x tends to 0 sine x into log x. Now what happened? Again I am getting into the second form, correct? Sine x into log x. So whatever the function it is, I know sine x can be written as 1 by cosecant x. Directly substitute it, then you will get the third one. Then apply the LHospital rule, find the finite value. So that this is the procedure, how you find that, or how you are applying the LHospital rule, and finally you will getting the finite value, right? And the next thing, to simplify or to evaluate any such problem by using LHospital rules, we must know some results, basic results. If you know that, you can apply wherever in the problem it appears, no, then you can apply that results. You can simplify the problem very easily. If not, suppose I forgot to apply that that results, can I get wrong answer? No, you will never get it. Okay, the thing is, it may lead to the another 2-3 steps, or it may take another 2-3 minutes more, and the chances of getting mistakes is very high. So that's the reason why, if you know this formula, okay, it's not a formula, sorry, if you know the results, then you can apply it and you can simplify the problem is very easily. So what are the limits? The results, limit x tends to 0 sine x by x equal to 1, then and its reciprocal is also 1 directly. Okay, I will explain why it is 1, correct? And limit x tends to 0 tan x divided by x also 1, then limit x tends to 0 1 plus x whole power 1 by x, that will give e. Now I will explain first and third. According to the first, you can find the second one. Okay, the first one, what is it given? That limit x tends to 0 sine x by x as a 1. Okay, limit x tends to 0 sine x by x as a 1 we want to prove. After writing the question or given function, immediately apply the limit, whatever the limit it is. So they are given 0, so I can write sine 0 by 0, that will give 0 by 0. Yes, we got the, what is that, a by b form. Now I can apply the LHospital rule. What the LHospital rule says, that you can differentiate the denominator and the numerator independently or separately. So I will do here, that is limit x tends to 0, what is the sine x will become cos x and x will become 1. Now apply the limit. In the denominator I have 1, so I can write cos 0 is 1, correct? And look at this value, sin x by x will give 1. That's what I have written, sin x by x is equal to 1. So you can save all these steps, or this time also you can save it. Similarly, you can prove the second one. Now I will prove the third one. So let us take some k. If I apply 0, what will happen? 1 plus 0, that will become 1, and 1 by 0, that will become infinity. Yes, we got the special case, 1 power infinity, correct? So how to simplify? First I will tell you whether it is 1 power infinity is 1 or not, and then we will go to the problem. Okay, and before that we will find it. So they told that it is indeterminate form, let it be. Okay, now we have the power, right? Now to do that or to simplify such a problem, we want to bring to the form a by b. For that I am going to take log on both sides. So what we will get? Log k is equal to limit x tends to 0. You know that log a power m log a. So directly I can write 1 by x into log of 1 plus x. Now again we want to apply the limit. If you apply the limit, what will happen? So log 1 divide by 0. Log 1 we know it is 0 by 0. Yes, we got the, what is the form? A by b form. Now we can apply the LHospital rule. What LHospital rule says? Differentiate the numerator and denominator independently. Yes. Now log k is equal to, what is the log x differentiation? That will give 1 by x. If it is 1 plus x, again we can write 1 by 1 plus x. So 1 by 1 plus x, and x with respect to x will give 1. So we can write it as 1 by 1 plus x, and before that don't forget to write the limit x tends to 0. Now substitute 0, what will happen? You will get 1. Yes, obviously. But look at this value. This is for log k, but we want to find only for a k value. So I am going to take exponential on both sides. So k is equal to e power 1. So that value, yes, I got it, e. So that's the reason why they told that this value will become 1. See, if you forget these results, you know what happened? You need to proceed all these steps. Okay. So and your time also may be getting high, and again I told you the chances of getting error is too high. So that's the reason why if you know all these results, you can apply immediately. And I'll come back to the 1 power infinity, right? Now to verify this 1 power infinity, we'll go from the basics. Okay, I will take 1 power 10 is equal to 1. Is it correct? Right. Why? 1 power 10, if you multiply 1 as a 10 times, you will get 1 only. Correct? So I will verify in the another method. Okay, if I am getting right hand side and left hand side are the same value, yes, we can say that 1 power 10 is 1 only. The same argument, to verify that, I will take log on both sides. So what you will get? Log 1 power 10 is equal to log 1, and this is the log a power m form. So how can we write? M log a is equal to, correct, that is 10 into log 1 is equal to log 1. We know log 1 is a 0. So 10 into 0 is equal to 0. What is a 10 into 0? That is also 0. Yes, we got it. Right hand side is 0, left hand side is also 0. Then obviously we can say that 1 power 10 is equal to 1. If you take any value, 1 power 100, 200, 300, 1 crore, 2 crore, or whatever it is, except infinity, because we want to verify that, because they said that it is the indeterminate form. Now we verify it. Correct? Now I will take in the assumption, or I will take as a contradiction. Suppose I will take as a 1 power infinity as a 1. I am assuming that 1 power infinity as a 1. Now we will do the contradictory method, that is opposite method, right? Again I will take the log on both sides. Log 1 power infinity is equal to log 1. Now this is the log a power m form. So infinity into log 1, that is m log a is equal to again log 1. We know log 1, right? We know log 1 value is 0. So infinity into 0 is equal to 0. Already we have mentioned that infinity into 0 as a indeterminate form, right? But 0 is the finite value. How can we say that 5 is equal to 100? So it is not possible. The same argument we can say that infinity into 0 is a indeterminate form which is not equal to 0. Therefore our assumption is wrong. That is 1 power infinity is not a 1. Correct? So this is also falls under the indeterminate form conditions. In the next video we will find the value of any function by using the LHospital rule. Okay, and thanks for watching.